The chameleon is a semi-automated sample preparation device. Initialize the chameleon. On the PC attached to the chameleon, open the chameleon software and verify that the system monitoring lights turn green. A startup checklist will appear on the Prepare Grids page. Open the bottom cabinet and confirm the bottle solution levels are correct. Connect the humidifier bottle and gently rock it. Bubbles should be observed, confirming the humidifier is being filled. Place a new tweezer cleaning vial and fill to the top with ethanol. Clean the sample vial using compressed air. Place it by gently releasing it directly above the sample holder to allow proper seating. Click the Home System button. This calibrates the system by zeroing out the position of the tweezers as well as the liquid nitrogen ethane box drawer. The software will advance to the Select Mode page. Enter the operator's name or initials and enter a name for the project. Click the Prepare Grids button to advance to the helium sparge page. Open the helium tank valves and click the sparge button. This process allows helium gas to flow through the bottle, degassing the solution, and takes approximately 2 minutes. Once finished, close the helium tank valves. Click the Continue button to advance to the dispenser setup page. The system monitoring lights will turn green and the doors will unlock. Open the doors and place a new methanol vial in the holder. Fill to the top with methanol. Click the Setup button to initialize the dispenser fluid system. The door will lock and the monitoring lights will turn white. Video of the dispenser initialization will show the back flushing process. The user should watch for particulates or debris in the dispenser tip. This process will take approximately 3 minutes. Click the Test Dispenser button. This will advance to the Test Dispenser page and the system will run an automatic initial dispense. Click the Automatic Test button to run multiple dispenser tests. The software will analyze the results. If successful, the dispenser tested OK message will appear. The default dispenser settings established during the installation should yield 4 to 5 separate droplets. The Troubleshooting tab provides different modes for cleaning the tip of the dispenser. This will help with proper dispensing if the automated test fails. The Advanced tab allows the user to increase or decrease the dispenser amplitude to ensure the correct placement of the 4 droplets. Click the Continue button to advance to the Load Cryogens page. Open the liquid nitrogen drawer by clicking the Open button, locating it to the Out position. Gently handle the styrofoam dewar by the edges. Place the liquid nitrogen styrofoam dewar in the liquid nitrogen drawer with the sensors facing toward the user. Once properly seated, click the Load Cryogen button. The liquid nitrogen drawer will partially close, and the software will detect if the liquid nitrogen box is loaded correctly. Pour liquid nitrogen directly into the ethane cup and surrounding dewar until the liquid nitrogen level in the dewar is nearly flush with the styrofoam edges. The temperature sensor readings in the side panel will turn red and drop rapidly from room temperature as the system cools. When the temperature reaches -173 degrees Celsius, the text will turn white and the liquid ethane can be prepared. Open the ethane tank valve. Place the chameleon ethane gas dispenser flush with the ethane cup. Once the ethane gas dispenser is placed on the ethane cup, the temperature sensor will read a higher temperature and the software will turn the ethane cup heater off to allow recooling. Once the temperature reaches -175 degrees Celsius again, press and hold the ethane dispenser button to allow ethane gas flow into the ethane dewar. Once the optimal liquid ethane level has been reached, carefully remove the ethane gas dispenser from the ethane cup and close the ethane tank valve. A white grid box can be added to the dewar. Once the white box is added, refill the styrofoam dewar with liquid nitrogen close to the top of the ethane cup. Click the Close button to close the drawer. Click the Continue button to advance to the Replace Grid button page. Enter the ID of the grid box. Click the Continue button to initiate tweezer cleaning. The software will automatically advance to the Load Grid page. The monitoring lights will turn green and the doors will unlock. Load grids and sample. Enter the grid batch number and grid box position information in the Load Grids panel. Set the glow discharge time in the duration input box located in the grid activation panel. Set the maximum number of grids to load in the glow discharge unit in the input box located in the grid activation panel. Using clean tweezers, carefully place the desired number of grids in the grid holder starting from position 1, located in the bottom left, moving away from the door. Ensure that the iridescent side of the grids are located towards the left of the instrument. This ensures that the nanowires are correctly located towards the dispenser for self-wicking post-sample deposition. Click the Continue button. The robotic tweezers will grab the first grid, starting from position 1, and place it in the glow discharge unit. If more than one grid is requested, each grid will also be placed in the glow discharge unit. The glow discharge unit lid will close, and vacuum will be pulled. The glow discharge runs for the requested duration. When the glow discharge unit is operating, a purple plasma is observed within the glow discharge unit. Additionally, the monitoring lights will turn purple. Once the glow discharge is complete, the software will automatically advance to the Prepare Sample page. Within the Volume to Aspirate input box, located in the Load Sample panel, enter the desired volume to load into the dispenser tip. Enter the information pertaining to the sample in the Sample Details panel for record-keeping purposes. Carefully pipette the sample into the sample vial, ensuring no air bubbles are introduced. Click the Continue button to initiate sample aspiration. Click the Dispense button to test the dispenser. To obtain the ideal 4 to 5 droplets with a protein sample, the amplitude of the dispenser may need to be adjusted and/or the tip will need to be cleaned. This can be done in the Troubleshooting tab. Once satisfied, click the Continue button to advance to the Plunge Control page. The robotic tweezers will remove the first grid from the glow discharge unit. Evaluate sample deposition and tune plunge times. By default, the two-stripe dispensing mode will be automatically selected. In the Test Wicking panel, click the Characterize button. One stripe is deposited offset from the grid center, and a video of the sample wicking is presented to the user for evaluation. This allows the user to evaluate the wicking time, and the software will recommend a plunge time for the second dispense stripe. Click the Plunge button to initiate the second dispense and plunge freeze. If the characterization grid in two-stripe mode is used for plunge freezing, the plunge review page will appear after clicking the plunge button on the plunge control page. In the Review Dispense Video panel, a video will show the wicking results. 6 images are shown below the dispense video. They represent examples of different wicking results for comparison. It is recommended that the user's result match closely to the very good or overwicked acceptable comparison images. The grid can either be accepted or rejected. If the user clicks the Reject button, the robotic tweezers will lift the grid from the liquid nitrogen and place the grid in the center of the grid holder. The software will advance to the Reject Grid page, and the user can give a reason for rejecting the grid. If the user clicks the Accept button, the robotic tweezers will place the grid in the next available white grid box slot. Confirm the grid is placed in the white grid box. The software will advance to the Complete page. Click the Lift Tweezers button when the grid has been properly stored. Click the Continue button to initiate the automatic tweezer cleaning process. During this process, the Accept Grid page will appear and allow the user to fill in comments and select the appropriate option to describe the grid. Click the Continue button to advance to the Another Grid page. If more grids are to be frozen, click the Prepare Grid button to advance to the Reload Glow Discharge page. This will allow additional grids to be glow discharged and frozen. If the user is satisfied with the two-stripe mode results, one stripe mode should be used for the rest of the grids. Before clicking the plunge button, it is recommended to click the test dispenser button, which will advance to the retest dispenser page. Then click the dispense button to confirm proper sample dispensing. Click the continue button to return to the plunge control page. In this setting, the user can manually define the plunge time and click the plunge button to initiate sample freezing. The software will automatically advance to the plunge review page. In the Review Dispense video panel, a video will show the wicking results. The Increase Contrast button can be clicked to help see the sample wicking results. Again, the user will have the option to reject or accept the grid. The software will advance accordingly as previously described. If the user is finished freezing grids or wants to load a new sample, then click the Finish Session button on the Another Grid page to advance to the Clean Dispenser page and to initiate the dispenser cleaning process. This will take 7 to 10 minutes. Once the cleaning process is complete, the software will automatically advance to the Test Dispenser page. Perform the test dispensing as described earlier in this video. If the user needs to load a new sample, click the Load Sample button. This will take the user to the Replace Grid button page. At this stage, the user may continue using the same white grid box if there are slots available. Click the Keep Grid button to keep the same white grid box. Otherwise, click the Open Drawer button. The user can move the current white grid box to one of the 3 styrofoam slots on the left side of the styrofoam doer and place the new white grid box in the white grid box collection slot. If the user does not need to load a new sample, then click the Continue button on the Test Dispenser page to advance to the Dry Dispenser page. The lights will turn green and the doors will unlock. Refill the methanol vial. Click the Dry button to initiate dispenser cleaning and drying with methanol. Once the dispenser cleaning and drying are complete, the software automatically advances to the Remove Cryogens page. Click the Open button to open the liquid nitrogen drawer. The user should cool the grid box cap in the liquid nitrogen before placing it on the white grid box. The user should move all white grid boxes to a separate doer. The styrofoam liquid nitrogen doer can be removed from the drawer slot and the liquid nitrogen ethane safely disposed of. Do not place the styrofoam doer back in the chameleon. Click the Close button to close the liquid nitrogen drawer. Click the Continue button to advance to the Finished page. If the user wants to save the results from the current plunge freeze session, this can be done by clicking the Create Reports button. This report includes information about the inputs and results from the session. Click the Close button. The monitoring lights will turn blue and the chameleon software will close. Grid evaluation in the transmission electron microscope. This protocol assumes the user has successfully clipped and loaded the chameleon grids into a transmission electron microscope following all technical and safety guidelines. The ice stripe within an atlas image can be more readily identified by adjusting the contrast using the histogram autofilter in the EPU Atlas page. The contrast can be increased by sliding the red bar to the right, darkening the image, and making the ice stripe more apparent. The ice stripe can be identified by first locating the thicker area of the stripe as highlighted here in red. Moving through the ice stripe, generally, the ice in the middle of the grid, indicated in yellow, is slightly thinner, while the area highlighted in green contains grid squares with the thinnest ice. Ice thickness can generally be evaluated by the level of contrast at the edge of the holes. Grid squares from the red area contain the thickest ice as they have the lowest contrast at the edge of the holes. The thinnest ice areas in green have the best defined holes with higher contrast at the edges. Representative results. The micrographs collected from the thinner areas displayed better particle distribution with more favorable CTF fits.